Hi, in this video we will add another rule to our toolbox of differentiation rules, which is going to deal with the product of two functions. So if I have two functions f and g and they are multiplied, what is the derivative of the product? This is, well, obviously why it's called the product rule. And what it says is that the first thing, the derivative of product is not, again, I'm saying is not product of the derivatives. This is given by the product rule. What it says is that you need to find the derivative of first one times second one, then added to that the first one itself 2 times to the derivative of the second one. Derivative of first one times second one plus derivative of the second one times first one, or first one itself times the derivative of second one. This is called the product rule. Again, the important thing is that don't use the product rule in the wrong way. Derivative of product is not product of derivatives. You have to apply this rule. Find derivative of first one times second, first one itself times the derivative of second one, and add them. Okay, so I have prepared some examples here for you. Let me just add it here. Yes, okay. Okay, so we have functions f of x, and we want to find the derivative. So what is f prime of x? So f prime of x, this is product of two functions. One is, let me do it like that so that you can see. One is the x plus 1, the other one is x squared. The product rule says what? Find the derivative of first one times the second one plus the first one itself times the derivative of the second one. This gives us what? Derivative of x plus 1. This is sum rule. So it will be derivative of x plus derivative of 1 times x squared plus x plus 1 times the derivative of x squared. This is power rule. So it will give us just 2x to the power 2 minus 1. Okay, let us simplify a little bit. Derivative of x is 1. Derivative of 1 is 0. And times x squared plus, this is, well, x plus 1 times 2x. Well, the final thing is that x squared plus 2x plus 1 times x. You can simplify a bit more, but we already did the power rule, product rule here, and then we apply all the derivatives at this stage. Derivative of first one times the second one plus first one itself times the derivative of second one. Let's do this one. G prime of x is going to be, well, I will write the derivative right away. So this is product of two functions. So we have to find the derivative of first one times the second one plus the first one itself times the derivative of the second one. Then we have to find, you see this term, we have not found the derivative, this and that. We have not found. So we have to go in and find derivative of this guy. So this is 2 times 1 over x. We have to find derivative of that using the sum rule. And that is the derivative of 2 over x plus 1. Well, I haven't found it, just applied the sum rule. Times x squared minus x, yes, plus 2 over x plus 1 times, now derivative of this piece here. This piece will give us sums of two things, so I have to add, difference of two functions. I have to differentiate each one and then find the difference. Now, one by one go in, so this will be product, the constant multiple rule. So this is 2 times, I can write 1 over x as x to the power negative 1 prime plus derivative of 1, the constant rule says it's 0, times x squared minus x plus 2 over x plus 1. Derivative of x squared is 2x, 2 minus 1, minus derivative of x, well, let's just use that one. Let me open a little bit space here for myself. Yes. And then, well, here we continue this thing. Derivative of, actually I know what is derivative of 1 over x. I told you to keep it in mind as a different rule. So here I can say it is negative 1 over x squared, or you apply the power rule. And then multiply plus 0, it won't change anything. Yeah. Then multiply to x squared minus x plus 2 over x plus 1 times 2 times x to the power 1, which is 2x minus 1. Yeah, that's another one. And this one comes in, well, first you look at it and say, well, there's no product. There's a power thing here. Yes, but it's not just x to the power 2. There's x plus 2 to the power 2. I cannot use the simple power rule here. But instead, I can see this as this thing. Now, if I want to find the derivative of first one times second one plus the first one itself times the derivative of the second one. And we'll apply the sum rule for this one. Derivative of sum is sums of derivative times x plus 2 plus x plus 2 times, again, this piece. Derivative of x is 1. Derivative of 2 is 0, constant. X plus 2 plus derivative of x is 1. Derivative of 2 is 0. And as a result, let me do a little bit more here again. Okay. No, what did happen? Okay, let me keep it that way then. So this guy here, it is 1 times x plus 2, so it will get x plus 2 here. This guy is also 1, so x plus 2, another x plus 2. So you add them, you get 2x plus 4. That's the derivative. Very nice. Those are the examples of product rule. Here we have again computing the derivative, but we are asked to evaluate the derivative at one point. Here at 1, here at 0. It means what? It means that you have to first differentiate, find f prime, and then plug in 1 into x in the derivative. So we have to start with f prime of x. You have to find this. This is product rule, so 3x plus 2 prime times x to the power minus x to 1 9 minus 3x. Derivative of first one times second one plus first one times the derivative of the second one. And now, this is 3x prime plus 2 prime sum, and then x9 minus 3x plus 3x plus 2 times x squared prime minus 3x prime. This is difference and sum. This is difference rule, yes. Derivative of differences is equal to, oh, this is 9, x to the power 9, not x to the power 2. Yeah, sorry. This is x to the power 9 here. Yeah. Now we find one by one. Derivative of 3x is just 3. Derivative of 2 is 0. x9 plus minus 3x plus 3x plus 2 times derivative of 9x is x9 is 9x to the power 9 minus 1, which is 8, minus 3x. 3 is constant, comes out. Derivative of x is just 1. Well, that gives us 3 times x9 minus 3x plus 3x plus 2 times 9x8 minus 3. We found the derivative, but the question asks for the value of the derivative at 1. So the value of the derivative at 1 is plug in 1 for x's in your function, in your derivative. 3 times 1 to the power 9 minus 3 times 1 plus 3 times 1 plus 2 times 9, 1 to the power 8 minus 3. This gives us 3 times 1 minus 3 plus 3 times 3 plus 2 times 9 minus 3. And that is 3 times negative 2 is minus 6. And this guy here is 5 times 6, which gives us 30. And that's 24. This is 5, this is 6, 5, 6, 30. And then that's. For this other one, again, we have to first find the derivative. So g prime at t is t2 plus 1 prime. Okay, let me do this one again. Oops. I have to do it again. G prime at t is the derivative of first one times the second one plus the first one times the derivative of the second one. This gives us derivative of t squared plus derivative of 1 times 3t plus 2 t2 plus 1 times 3t prime plus 2 prime. And what this gives us is 2t plus 0 times 3t plus 2. Add to that t2 plus 1 multiplied to derivative of 3t is just 3 plus 0. And what we have 2t times 3t plus 2 plus t2 plus 1 times 3. Now we have to evaluate this function at t equal to 0. So this will be 2 times 0, 3 times 0 plus 2 multiplied to that, plus 3, 0 squared plus 1. The first piece, everything is multiplied by 0. It will be 0 plus 3 times 1, which is just 3. Derivative of first one times second one plus derivative of second one times the first one. Okay, for this one, here we are asked to find the equation for the tangent line. Remember, to write an equation for tangent, for any line, we need a slope and we need a point. A slope well, let me denote it by m, is going to be derivative of that function at that point. So we have to evaluate, find the derivative and then evaluate it at 0. The point through which the line passes, the tangent line passes, is, well, 0, the same point with the same x, f at 0. So we have to evaluate the function itself also and then use it for the second component of the point. So here, what is that second component? Plug in 0 there, so it will be 0 cubed minus 1, 0 squared plus 0 plus 3. So 3 times negative 1, that will give us 0, negative. So we have the point, we have to find the slope. It means that I have to find what is the derivative of function. This is x cubed minus 1. Derivative of first one times the second one, plus the first one itself times the first one itself times the derivative of the second one. I will do the differentiations a little bit faster now. X cubed, power rule you apply, it's 3x squared minus 0. And for x squared plus 2, it will be 2x plus x, the derivative is 1, derivative of 3 is 0. And, well, that gives us what we were looking for. The derivative is 3x squared times x squared plus x plus 3 plus x cubed minus 1 times 2x plus 1. So we have f prime. So if we plug in 0 into that, we get the slope. It means that we have 0 squared plus 0 plus 3 plus 0 cubed minus 1 2 times 0 plus 1. This, the first piece is 0 plus negative 1 times 1, which gives us negative 1. So the slope is negative 1. We have the point, we have the slope. Y minus y1 is equal to m times x minus x1. Y minus y1 is negative 3 equals to negative 1, m is negative 1, x minus 0. So we have x plus 3 equals to minus x. Well, just write the general or the standard form of the equation. So this is an equation for the tangent line at that point. And the very last example, we are trying to find what is the derivative of functions which are given in terms of another two functions. We don't have what are the these two other functions. We only have a table of values for these functions. So f at 0 is 1, f at 1 is 2, and so on. Now the question is find h prime at 0. So I have to first see what is h prime itself. H prime itself is the derivative of these two guys, yes? I have to write this in a little bit. F of x times gx, that's what it means for h. Now, we have product of two things. I don't know what are f and g, but I know how to find the derivative of product. So f prime times gx plus fx times g prime of x. That's product. Yes? Now, if I'm looking for h prime at 0, it means that I have to find f prime at 0, multiply to that g at 0, plus find f at 0 times g prime at 0. Well, now I can use the values from the table actually here and just find it. F prime at 0. So f prime at 0, this is the value. It is equal to 2. G at 0. G at 0 is this times -2 plus f at 0. This is f at 0. This is 1. And g prime at 0 is 3. So we have -4 plus 3, which is -1. How about the other one? Well, h prime x is going to be derivative of this whole product of two pieces which involve f and g. Now we can apply the product rule. So this will give us fx plus 3x prime times x squared minus gx. Derivative of first one times second one plus first one itself times the derivative of the second one. Now, this is sums of two things. I have f prime at x plus derivative of 3x times x squared minus gx plus this is f at x plus 3x times derivative of x squared minus derivative of g. Let us complete these steps. So this is f prime of x. I don't know what is f prime, but it is f prime plus f prime derivative of 3x is 3 plus f of x plus 3x times derivative of x squared is 2x minus derivative of gx is just g prime. Now we are trying to find what is h prime at 1. It means that I need to use these values up there. Okay, let me just copy this and maybe I just cut it and bring it down like here. Yep. So now f prime at 1 is this value. So it will be 0 plus 3 times x squared, so 1 squared minus g at 1. G at 1 is 1 plus f at 1. This is the value of f at 1 plus 3 times 1 times 2 times 1 minus g prime at 1, which is 1. This gives us 3 times 0 plus 5 times 1. This is 0 plus 5, which gives us just number 5. And this was, well, we did tons of examples for this and product rule. This was what we were trying to cover. Derivative of first one times second one plus the first one itself times the derivative of the second one.